Howdy, my name is Frank Hall. I'm a director of data science and analytics at an energy consulting company. My team's primary role is predictive analytics for supply, demand, and pricing. But today I'm here to talk about computer vision made easy and Cusco. The topics I'm going to cover today, first I'm going to kind of go over what a typical computer vision framework would look like. Then I'll discuss what prompt-driven computer vision is. Then I'll discuss structured outputs for structured analysis, so making sure that what comes out of an LLM is ready to go for an analysis. Then we're going to dive into Cusco as an analysis toolkit. And then lastly, I'll be discussing what's new to Cusco and what's coming soon. So to start us off, the typical deep learning computer vision framework, let's break that down into a few different steps. So we could build our own computer vision model with TensorFlow, but I would say that this probably has a steep learning curve, and you should be expected to have some esoteric knowledge about neural nets, deep learning, and understand how to build a computer vision model from scratch. So you may not want to go down that route. Nowadays you could use something like Keras or Torch as a less steep learning curve. But you would still need to understand what tensors are, how to stage your images and your labels associated with those images. And then lastly, there could be the opportunity to use a pre-trained computer vision model. So thinking about downloading a ResNet and using that for your own purposes. I would say that that has the least steep learning curve, but you would still need to fit this within one of these three frameworks that I discussed previously. So the issues faced by an analyst for training a computer vision model. I've already mentioned that it's a steep learning curve. I've mentioned that a few times to preface the fact that it's, even if you understand Python or R or data wrangling or machine learning, it is a brand new field to you when you dive into it. So there's quite a bit that you might need to learn just to be ready to train a model. And you know, as soon as I say tensor, everyone says, whoa, what are you talking about? So understanding what tensors are and how those relate back to deep learning. You could also have other issues. So maybe you have limited images for training. So say like I want to build my own computer vision model. I want to understand the differences between Corvettes and Ferraris. I need a lot of images of Corvettes and Ferraris. Do I have all those images? Probably not. So the idea of building one from scratch, you need a lot of images to even get started. Next, you also need these labels associated with the images. So if you're going to curate your own images and create your own labels, are your labels limited or incorrect, or maybe you did like a fuzzy matching of labels to images, or maybe you're using some predefined labels and the labels don't fit your exact needs. In addition to that, you still need to process your images, and with whatever model you decide you want to build, you are subject to the context of the size of your image and the tensors associated with training off of that image. When you want to do inference and you don't have these images yet, you need to have those images match the training data images. So that can be a little tedious. Okay, so maybe we've decided that we don't want to train a model. Maybe I've talked you out of training a model completely, and you want to use a pre-trained computer vision model. Now from here, you've skipped training everything's good, everything's great, but you're using a pre-trained model with a predefined context. So you downloaded a pre-trained model, it says it's really great, it has over 1,000 labels that it's been trained on, but those labels don't exactly fit the need that you're trying to do. So maybe you're trying to apply this to cats and dogs, and you really just need to know the difference between a cat and a dog. But your pre-trained model is a generalized model. It knows the difference between stop signs, stoplights, cars, dogs, cats. Maybe you really want to know the specific breed of dog. And now you're limited within the predefined context of whoever trained that model. And then still, image processing for inference. If you want to create a good label for an image, you need to have it, the image processed in a method that fits the predefined context of the trained images, if that makes sense. So maybe you've decided you're not going to do computer vision at all, or maybe you're like thinking, maybe I could do a pre-trained model, but it's still a lot to it. So maybe let's think of a completely different idea. Maybe we will use LLMs and treat LLMs as pre-trained models. So they are pre-trained models. They're trained on various data types, whether that be books, blogs, Stack Overflow, PDFs, images, videos, memes, etc. They have built in a pre-trained model that's a deep learning neural net. It processes images as tokens, so we don't need to really worry about pre-processing our images. We can allow the tools that are available to us, plus the LLM, to process the image for us, which is pretty neat. And they have a large amount of text and image context. So the idea that you may want to label dynamically or change the way that you label within an analysis, you can tell this LLM to label your images differently. So this is kind of the bulk of Cusco. Cusco uses LLMs as pre-trained models. So instead of using a typical computer vision workflow, we're using LLMs. So since we are using LLMs, now we've entered this space of prompt-driven computer vision. So instead of like training a neural net on images and labels, we're going to prompt engineer an LLM to be a computer vision model. And so that's pretty easy to do. You can give it a role within the system prompt and you say, you are a specialized AI model functioning as a high-precision computer vision engine. So this is one sentence long. That's pretty much as simple as you can get to tell this LLM to act as a computer vision model. From there, you can layer on additional sentences and context and structure so that whenever you're doing this LLM prompt engineering, you could do this for classification, you could do this for object detection, image sentiment analysis. Say you want to create alt text for an image, you could do that. Or say you want to just do some sort of OCR text extraction from an image, this can also work with the LLM. So we're creating prompts for the LLM to then take our image and give it a label. Additionally, within Cusco, we have this structured outputs. So one thing when you're messing with LLMs that's kind of cool is that it has thought streams, it's streams of text that can help you do XYZ at home, think through, brainstorm on a few different ideas, or help with code. But it's very unstructured and not very nice for any kind of analysis. But you can tell an LLM to return their context in a structured manner. And so that's another thing that Cusco does. You can organize everything in JSON form so that you expect your return to fill a specific JSON format. And then Cusco, what it does internally is converts that JSON format into a data frame. So this makes it super easy if you're doing some sort of image analysis and you're using Cusco and you want to analyze the outputs. These are data frames with columns and rows. So it makes it really easy to kind of build an analysis framework around Cusco. So we've kind of gone over the system and image prompting for Cusco. We've also discussed structured outputs and how Cusco handles its outputs. But as a computer vision toolkit, I also have built like a few different input and output helpers and a Shiny application. So kind of making it a one-stop shop for any kind of computer vision analysis that you may need to do. And you can see here, super easy to install Cusco through GitHub or R Universe. You can install it with one line of code, either through DevTools or Pack. So from an input stage, here we are just loading Cusco, the library. Within Cusco, I already have a test image within the package, so I'm saying that's my image. And then we have this view image, so we can easily view an image. This was something that I thought was a little bit tedious when I first started building Cusco, is how do I view an image in R? I hadn't really done too much with images and having to view it within the console or within the viewer pane or something like that. So it kind of made sense just to add a view image function, something super simple, but super helpful, I felt, as I was building out this package. So you can view images very easily. From here, kind of validated you have an image that we're trying to do some sort of computer vision to. Here's an example of building a classification. So we have LLM image classification. Cusco kind of follows that LLM image and then some action that you're trying to do. And here we have arguments for image. We're going to assign my image from the last slide. We're going to give this a provider. The provider could be a local LLM provider, Ollama being one of those. But the backend, when it's set to Elmer, this could be any hosted LLM as well. So Anthropic, Mistral, OpenAI, Google. You could switch this provider with any of the LLM providers that you know of. In addition to that, you have the LLM model. So you can set that to any model that any of the providers provide. So for Ollama, and the examples I'm going to be showing today, I'm going to be using Quinn 2.5 VL. Quinn 2.5 VL is a vision language model, so it's been biased towards images and vision. So it's within its name, it states that it's been trained on additional images, so it should be able to help out with any kind of image processing, which is pretty slick. So we have our image. We also have this view LLM results helper that's part of Cusco to help out the analysis toolkit. So this creates a GT table with the columns now as rows, so you can quickly and easily view the output from an LLM. I thought everything going into the console becomes a little tedious to read, so I thought maybe like a GT great table output would be a great way to showcase the computer vision results. So that's also part of Cusco. We have our image classification. It says the portrait of a dog. Primary object is a puppy. So I think we're good. Everything's kind of working as planned. And this is a pretty good example of classification. We also have alt text. So Cusco can do any kind of alt text. Say you're like building out a package and it has 50 different images or you're working on a report. I actually added alt text for this very reason, is I didn't really want to create alt text for every image that I had associated with this document that I was writing. And I've also found out that I'm not the best at writing alt text, so I thought, hey, maybe Cusco could use like a LLM image alt text function and write alt text for me. So here's an example of what an alt text would look like for the test image. It says a black and white puppy with spots looking directly at the camera. Another example that works really well in Cusco is image recognition. So this has an additional input parameter instead of just image provider LLM model backend. We also have this recognize object. So this could be anything that you're searching for, whether it is within the image or not. So the idea being that you could search for just about anything within images, number of faces, number of eyes. Here I'm looking at a nose. I know there is a nose inside of this image, and so I'm going to do an image recognition, the object recognized, so it's true, object count 1, the description is a close-up of dog's face with a nose that's prominent in black and it's in the center of the image. So this is a pretty cool way that you can use Cusco to like loop over different images if you're looking for a particular object. Also within Cusco, that is a little bit newer, but not as new, is this Cusco app. So there's a Shiny app built inside of Cusco that you can launch at any time. And so this allows you to do a completely no-code solution. So now you have an application, you can select which function you want to use, you can select a backend, which model that you want to use, you can browse your computer for a different image, and then you click Run LLM, and then it produces the result on the right with a confidence score, if it was able to extract that text and how much confidence it has within itself to extract that text correctly. So this is a pretty neat kind of developer tool, analysis tool, and kind of like a testing playground. In addition to that, the way that Cusco is written is a modular framework, so you should be able to kind of add and subtract different functions as needed, and you can hit up different cloud providers as necessary. You could do image classification with 3 different models. Here's like a very simple vision workflow where I'm using Pixtral from Mistral to do image classification and image sentiment, but then I also have a Quinn classifier as well. And then using per, I can just map a list of images to this workflow and have a list of outputs and results very easily. And you can add and subtract these functions and create any kind of workflow that might also be up or downstream from a particular machine learning workflow as well. So some of the things that are new to Cusco, I really enjoy this custom image custom function. So something that we built over the summer. You can kind of see it here below. We have the ability to completely write a system prompt, an image prompt, and give it an example data frame. So this is nice. So if you need to loop over many images and you want to be able to bind them easily, you can give it an example data frame so that the LLM will know what kind of JSON to provide back. But here I have this system prompt that just says you're a dog breed expert, you know all about dogs, and then the image prompt is asking what kind of dog is in the image. And then I have this dog breed primary, dog breed secondary, and dog breed information. And you can see the dog breed primary, Australian cattle dog. That is correct. So Quinn 2.5 VL does seem to know a lot about dog breeds, which is kind of weird. Uh, I've ran this a few times, and my dog is like a weird GSP cattle dog mutt, and a few times it guesses this correctly. Sometimes it doesn't. It's here, like he's not a Dalmatian, but he is spotted, so it could be easy to confuse a cattle dog, a GSP, and a Dalmatian. So it's pretty interesting how well Quinn 2.5 BL works at, in particular, classifying dog breeds. That's kind of what was new, coming soon. I think that we should have additional developer tools added here soon. So that's part of the roadmap, is being able to edit the system and image prompts within the package itself. So having like an editor toolkit that will allow you to do iterative testing quicker, easier. That's built into the package that allows analysts to kind of like tinker with the prompts. Say they are using a different LLM and these prompts work. Maybe these prompts are really working really well for Quinn. Maybe they're working really well for Mistral, but they're not working very well for Gemini. And someone wants to come in and edit that, the system and the image prompt. We're going to make that a lot easier. And then lastly is it's been almost a full year since Cusco has been on my GitHub, and I think when we get a few more things tied out, pushing the package to CRAN. So having a CRAN release is also on the to-do list. So something that I'm looking forward to, maybe part of the 1-year anniversary of Cusco. I appreciate you all listening to my talk. I guess I'll be open for any questions live. Appreciate you all sitting through this discussion and looking forward to answering questions.
Hi, all. Thank you for joining us today. I'm Lou Bajic, the moderator for this session. Want to thank Frank Hull for that great talk on using LLMs for computer vision. Frank is the Director of Data Science and Analytics at ACES. And so, Frank, thank you very much. We've got one question in the Q&A, and anyone else who'd like to ask questions, please put it there. We've got about 11 minutes before the next talk starts.
Awesome. Yeah, thank you so much, Lou. Yeah, so I see the first question here. It's about Cusco. Can it quantify the amount of wear in an image of a gear provided a pristine gear dimensions? This is interesting. So I think I haven't done any kind of like side-by-side comparisons, say like giving it multiple images saying, hey, this is a perfect image. This is the image of another gear that has wear and tear to it. That's not part of the package right now, but you could try maybe with like the LLM image custom to customize it for gears and say like, hey, I'm just trying to evaluate gears, hoping that the LLM has been trained on some images of gears, right? And then you give it these images of, dirty, rusty gears, and then it might be able to say like, oh yeah, this is 70% wear and tear. But be careful when you're receiving numbers back from the LLM, of course.
So while we're waiting for another question to come in, Frank, you talked a little bit at the end about your plans for Cusco next. Anything you're particularly excited about doing with Cusco or computer vision in the near future?
Yeah. So, there's a few other developers tinkering with Cusco here and there. It's kind of like a side project for about 3 of us spread across the world, working on the weekends and evenings. I'd love to spend a lot more time on the project, adding RAG to image processing. I think that there's another open issue related to image generation. I don't think there's a lot of there's not a lot of tools in R to kind of do image generation, and R is kind of not as far in AI, and Cusco's now become this shop where it's like, oh, it's a computer vision LLM framework, like just jam everything in there. So I think we can do that. We haven't had to split the package into 2 or 3 pieces yet, but I think, maybe doing this computer vision analysis, doing maybe some RAG, maybe doing some image generation, and kind of being like a one-stop shop for all kinds of image processing and AI tools and how images and AI come together, kind of being in Cusco. Yeah. So very excited for
Very
that.
cool.
Yeah.
Very cool. Looks like there's a question in the chat from Dante Ramirez.
Okay. So this is so does the argument where my image was handle multiple images? So right now it's more of something that maybe you have a list of images and you would map those images to the function. So right now, I don't think we allow, I don't know if I've even tried it to just try to like throw 2 or 3 images into the function at once. Um, I'm thinking about the way that the Elmer backend is set up is different than the Olamer uh, backend. So it might work with Elmer, but I would have to test that. That's a good question. But yeah, the idea being that you would take a list of images, map the function, and bind those maybe with like per map was the idea, and that's how you would kind of get that into a data frame.
Huh? All right. Oh, there's some more questions came into the Q&A. Excellent.
Awesome. Sorry, I'm jumping around between the chat and the
Mm,
Q&A here.
me too.
Okay, have you compared the performance when identifying images specific to the utility of asset management versus embedding tools in vendor software? I have not, and I'm not even sure if I know exactly what that question means, so I apologize there. Um, so let's see here. Another question. What is the main benefit of using something like Cusco versus uploading images to a web-based LLM? So I'll stop there because I think when I initially built the Cusco was with Olamar, and the idea being a local LLM toolkit. So that the idea being that everything's private. Maybe you have inherited a box of family photos from your grandmother, and they're completely undigital, and you don't really want them on the web. So the idea of being able to use Olama and Cusco to process family photos. You're doing this, it doesn't really matter how long it takes. Maybe it's not the fastest method if you're using some state-of-the-art AI on the web, but uh, you would have this analysis data that you could kind of arrange and look through, and maybe you could group images by, if by year. You could almost make a family timeline group where your grandparents together versus the grandkids, and like actually build these kind of like dynamic timelines of like maybe family photos that you don't want these images to be part of the training data is kind of the concept with the Cusco.
I love the idea of using Cusco to create your own family timeline by recognizing the images and organizing them for you. That's very cool.
Yeah, yeah. I I had talked to a few friends, and like that was one of the concepts that like started Cusco. Another concept, without like naming anybody, but was trying to identify different cars. And it's like, and I kind of spun that into dog breeds, but really for cars, it's kind of like, is it a car or a truck? Okay, that's easy. Well, like what vintage red Ferrari is this? I don't need to know if it's a red car. Like, is it a Ferrari or a Porsche? Uh, and then that's where we started to think like, Oh man, this is going to take so many images of cars, like this computer vision model. If we want to do this project, the side project, it's going to take forever. I wonder if we can kind of just hack it out on top of an LLM. So that's where Cusco just kind of we started. It was an idea for at least a year before we started working on it, and it's been almost a year. So yeah, I like the family photo idea. I'm sure there's some other ideas people have. Another one that I had was just kind of like whenever you're hiking, you don't have internet and you just want to like try to like identify trees or flowers that you don't know. And it's just like, I'm just kind of out here. I'm used to having my phone. I don't have any information. Like, can an LLM help me? Maybe. So that was kind of the idea of building on top of a llama. Um, just trying to see if there's any other questions that popped
Yeah.
up.
Yeah, it doesn't look there are. So, the next talk is starting in 2 minutes. So we'll go ahead and wrap up. Frank, thanks again for a great presentation and just a very cool package. So
Yeah, thank
really
you.
very happy with it.
Yeah, I appreciate it. Thank you.
All right. Thank you all and see you all in the next talk.